see, these are, potential test 3 questions. So I'll just, start class here by going through the solution with you guys. And let's see, so like the first one actually could well have been on test 2, right? If I recall correctly. So we'll start with that one. And I will solve them over here. All right, so we have the integral of x plus the square root of x over the cube root of x. Okay, so here we've got x over cube root of x plus the square root of x over the cube root of x by algebra. And so that's really x to the 2/3 plus x to the, this is half minus a third. A half minus a third is a sixth. Right? And then we do the usual power rule. So 2/3 plus 1 is 5/3. So we get 5/3 for the power. We have to divide by 5/3, which is the same as multiplication by 3/5. So we get 3/5 x to the 5/3. And then 1/6 plus 1 is 7/6. We divide by 7/6, which is the same as multiplying by 6/7. X to the 7/6 plus a constant. Now, you may have written your answer in terms of square roots and stuff, so like I'm not 100% sure you were right or wrong if you write your answer using square root. Like I didn't do the arithmetic in my head. It looked like you had, some of the right steps, but you can be the judge of whether or not, it was 100% right there. But there you go. Of course, as always, if you have questions, just interrupt. Number 2, we're faced with the integral of, what was it? I've already forgotten. Sine squared x cosine x dx. So what do you guys think we should do here? Looks like a u substitution, doesn't it? We should let u equal to what? Yeah, u equal to sine of x. So du is cosine of x dx. And with that substitution, we have u squared du. Right? Because the cosine of x dx is just literally right here. And this is u squared under that substitution, right? Okay, so that is 1/3 u cubed plus a constant, which here is 1/3 sine cubed of x plus a constant. There you go. I think everybody got this problem, so, or we're pretty close at least. Number 3, and okay, once we get done looking at this quiz, make sure I give you guys your homework problems back, because I did look over your homework and graded them right quick before class. Not super critically, I will say. So you should always refer to my solutions, as you're studying. Oh yes, so we have integral from what, 3 to 4? Of x cubed ex to the fourth dx, right? So what do you think we should, it's a u substitution problem, right? What should we make our u here? Dx to the fourth, very good. And so if we do that, I think that's the right choice. U equals x to the fourth. Okay, so then du is 4x cubed dx, right? And so if we want, we could solve for dx. dx is du over 4x cubed, right? So we're looking at integral of x cubed e to the u du over 4x cubed. That's good. Looks like the x cubed are canceling, right? But what about the bounds? Yeah, x equals to 4 implies u equals to a big number, 4 to the fourth, right? And x equals to 3 implies u equals 3 to the fourth power, right? And what are those numbers? 16 times 16? No, wait a minute. It's 2 to the 8th. I want to say that's 256, is that right? And 3 to the fourth, well, that's 9 times 9, that's 81. Right? Was that right? Okay, good. So there you go, that's the substitution, right? And put it in practice over here, so I'm going from 81 to 256. And so one more step here. This gives me 1/4 integral from 81 to 256 e to the u du. Of course, the antiderivative of the exponential is just the exponential again here. And fundamental theorem of calculus part 2, got to evaluate from lower, f of b minus f of a. So that is 1/4 e to the 256 minus e to the 81. And I would not, I think that that's like too big a number to probably, your calculator is probably not going to do a good job on that one. I don't think. It's a pretty big number. Does that make sense? So, the thing here that's kind of a pain is the changing bounds. But I hope the u substitution here wasn't too nasty, right? Now, students often, I'm going to do number 5 next, just because it fits here, like board space wise. Like number 5 is actually really easy. Where ddx of the integral of e to the x to, what was it? Sin x. And then some horrible function, right? The tangent cubed, hyperbolic tangent cubed of the square root of t plus cosine of t. Is it t squared or t cubed? What do I put there? T squared. That's quite horrible, right? So you cannot directly integrate what's here. Like, this is not an integral that you can do. You have to use the fundamental theorem of calculus part 3 to do this one. So we'll use which FTC3, as I call it, is basically FTC2 with the chain rule. So what you do is you take whatever this is. I'll just write it symbolically for a second. Let's call this thing f of t, all right? So what we do is you take f of b of t times db dt minus f of a of t times dA dt. Now here, this is b of t. Excuse me, I'm an idiot. Did I say dt? No, I should do what? These are of x's, aren't they? I'm a dummy. Sorry about that. So this is b of x. This here is the a of x. So the only differentiation that you have to do is actually differentiating the bounds. And the only other thing you have to do is just evaluate the integrand at the bounds. So in this case, this is hyperbolic tangent cubed of the square root of b, which was sine of x, plus the cosine of sine squared x. All of that mess gets multiplied by the derivative of b, which in this case is cosine. And then we subtract f of a of x. And f of a of x is, well, I just got to plug in e to the x in for t. So square root of e to the x plus the cosine of e to the x quantity squared. And then I have to multiply by the derivative of a, derivative of e to the x, which is e to the x again. Yeah, just e to the x. And so I'll put it on 2 lines, but there you go. That's the answer. So the most of the work in this problem is just writing the answer down. I mean, honestly, like it's just a pain to like actually do those evaluations, right? F of b of x and f of a of x. But don't be scared of this problem. Just recognize what we have to do. We have to use the fundamental theorem of calculus, part 3. Or if the bounds are nicer, if the bounds are just like x and a number, you can use FTC1. Okay, so let's see here. Now let's do number 4. Area bounded by x equals to 9 minus y squared and x equals to y squared minus 9. Now, if this was a problem on the test, I would try to also include another sentence, which was like, please include a picture of the area you're calculating and indicate your typical approximating rectangle, you know, or your typical infinitesimal rectangle. Okay, so what are these? Like 9 minus y squared is a parabola that what? It opens to the left, right? Its x-intercept is 9. When y equals to 0, x equals to 9, right? You can also factor this. This is 3 minus y, 3 plus y. This one here is y minus 3 times y plus 3 for what it's worth, right? So that shows you that the y-intercepts here are actually plus or minus 3 for both of them. Now this one is it's got an x-intercept which is -9. It's like over here, and it opens that way. So these are both parabolas. They're sideways opening parabolas, and you know. So let's see here. I'll try this one. So in the yellow, I've done x equals to 9 minus y squared. And I usually say that, well, that's the right x, right? And on the other hand, this one, this would be the left x, right? XL is y squared minus 9. Where are the points of intersection? You know, XL equal to XR gives us points of intersection. It's already clear from what I've written on the board, but let's like work out the algebra again, just as a model of how to do these problems, because when they're more complicated, like the problem we worked in class before, it wasn't at all obvious where the points of intersection were when we looked at the parabola with a line intersecting it, right? So like this is a good practice to get in here. So we have y squared minus 9 equal to 9 minus y squared, right? Which gives us 2y squared equals to 2 times 9, which gives us y squared equals to 9, which gives us y is equal to plus or minus the square root of 9, which is plus or minus 3. So this point right here and that point right there, those points of intersection are in fact at plus and minus 3. Ooh, there's like a scratchy thing inside this particular blue chalk. 3. Down here, minus 3. And so how are we going to do this? Are we going to look at vertical rectangles? Are we going to look at horizontal rectangles? Like, what's the right way to divide this shape up to find the area? Right triangle. Well, I mean, typically we either did something like this, right? We had like this, and so we, you know, DA was like that, or the other thing we had was like things like this, and we did like that. So DA was like this, you know. Those are the kind of two flavor options we have here. I mean, you could go either way, right? You could make, of course, you could put vertical rectangles here, right? But that would be annoying because then like the top and the bottom are both from the same formula, right? Then you have to like break this up into plus minus like root functions. I think like the easier way to do this is to look at horizontal strips here, like that. See, because then the thickness is dy, right? And the width of the strip is the right x minus the left x, right? So dA is what? Well, dA here is, well, just like I said, xr minus xl times dy. And so that is 9 minus y squared minus parentheses y squared minus 9, right? Which is, in fact, 18 minus 2y squared, right? And this is for what? For what y? So this is for minus y less than or equal to minus y. Listen to me. Try that again. Minus 3, right? That's the lowest one, all the way up to 3. So we do minus 3 less than or equal to y. It's important to figure that out because whatever you write for that inequality, that informs how we write down the continuous sum to get the area, the integral. And so the area is the integral from minus 3 to 3 of, well, 18 minus 2y squared dy. Now, you could just do that integral as it's stated, or we can make our life slightly easier by using the even integral trick. Right? This is the integral of an even function. Right? This is an even function in y. The integral's from minus 3 to 3, right? So we could just double the integral from 0 to 3. It's nice to do that because when 0 is one of your bounds, the evaluation at 0 is nicer, you know? Like it saves you some arithmetic. So this is 2 times the integral of 18 minus 2y squared dy from 0 to 3. And just one more bit of arithmetic here. I'm going to factor a 2 out. So we got 4 integral from 0 to 3 of 9 minus y squared. I guess I should have left that. Fine. At some point, I'm actually going to integrate and stop doing silly arithmetic, but I mean, you could do that. And of course, you could have just integrated the original thing just the same. I mean, it's pick your poison, what you want to do here. So that's 4 times 9y minus y cubed over 3. And that goes from 0 to 3, right? So that is 4 times 9 times 3 is 27. 3 cubed is also 27. And so what does that work out to? So 27 over 3 is 9, right? 27 minus 9 is 18. Eighteen times 4 is 72. Oh, cool. I'm just thinking, when y is equal to 2, or when y is equal to plus or minus 2, x is equal to what? Y, when in these curves, when y is like plus or minus 2, you got like 9, either got 9 minus 4 or 4 minus 9, you get plus or minus 5, right? So when x is equal to 2, when y is equal to 2, right, like here and here, you're at plus or minus 5. So I'm just thinking about like this box is inside the area we're calculating, you know? And this box is going from like 5 to minus 5, and it's going from 2 to minus 2, you know? In other words, it's a 10 by 4 box. It's got 40 in it. So I think the answer is 72 is reasonable because you can see that there's like this 40 area box inside the area we're looking at. So apparently these little excesses here, 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 and here must come up to 32, which even with the sort of rough sketch I have on the board, I think that's a reasonable answer. It's often, my larger point here is like it's always a good idea to just stop and take a second to ask yourself when you have an answer, like, is it a reasonable answer, right? The most common mistake with these kind of problems is people like will flip the area over make the left the right and the right the left, or make up down and down up. And when you do that, you'll get the right number for the answer up to a sign. Instead of getting 3, you'll get -3 or something, right? So if you get -3 as the answer for an area problem, you probably should go back and ask yourself again, when you set up the DA, was your picture right? Or did you accidentally just flip the top and the bottom, you know? So that's often easy to fix. And even if you run out of time on a test and you just write a comment that says, I know this is wrong, area should be positive, I must have flipped the DA or something like that, I will give significant partial credit for such a comment because it shows to me the student is thinking and is concerned with the things that matter in the course. Now, number 6, finally, we're given the velocity, right? And we're asked to find the position and the acceleration. So how do you do that? So v, which by the way is equal to dx dt, right? If it's velocity. And that's equal to 3t plus 2, right? And the acceleration, well, that's dv dt, right? By definition, right? The derivative of the velocity is acceleration. So let's do the acceleration first. That one's, you guys tell me, what's the acceleration? Using calculus. The acceleration is the derivative of the velocity. We don't need formulas. We create our own. What's the derivative of 3t plus 2 with respect to t? You are integrating. So like, yeah, this would say that x of t, or just, I'll just write x is equal to, 3 over 2 t squared plus 2t plus some constant, right? If we take the antiderivative. That would be position as a function of time. We don't want the C1 in our answer though, right? But we'll get back to that. How about the acceleration though? This is easier, right? What is acceleration? Just 3, exactly, yeah. So the acceleration is 3. Found that position is a function of time. So guys, something I should confess is I don't always write. I debate endlessly over this in this course. And a given problem is like, is it helpful for me to write this? Or is it better for you guys if I just write that? You're like, well, so sometimes we just write x equals the function, right? But technically speaking, this is x of t. It's x as a function of time. This is not multiplication by t, right? This is x of time t. It's function notation. And so let's see here. X of 0 is what? It's 3, right? But that's 3 halves 0 squared plus 2 times 0 plus c1. Right? Equal to 3, which tells me that what? C1 equal to 0, 0. So yes, C1 is just 3, because the other two things there are 0. The equation above gives us 0 plus C1 equal to 3. So, and now I can take that and I can put it back into the formula for position. So, thus, answer, acceleration is equal to 3, and position is 3 halves t squared plus 2t plus 3. And you could just as well say a of t is equal to 3, and x of t is 3/2 t squared plus 2t plus 3. Some instructors would insist on writing what I just wrote underneath it as being correct, whereas what I have above is not correct. I'm open-minded. I allow either answer. So in summary, if you're given velocity, differentiate to find the acceleration, integrate to find the position. But when you integrate, there's a constant that comes from the anti-differentiation, right? In order to fix that constant to make it a specific number, we need to be given an initial condition like that. Otherwise, we can't find a specific formula for position, right? Okay, so that's it. That was your quiz. I mean, that's kind of a micro test 3. The real test 3, of course, will have like much more u substitution on it and much more just make integrals of the sine, cosine, tangent, all that stuff. Probably a couple area problems. Certainly there should be a physics, velocity, acceleration, position problem. What else have we covered? I might ask you to state the fundamental theorem of calculus. That's the main theorem we went through, right? In terms of left, right, midpoint rules, I think the main question would be like a conceptual question. For example, if I give you a function, right, and it's increasing, from A to B, then if I was to say integral from A to B, f of x dx, less than or equal to blank, greater than or equal to blank, fill in blank. With the right endpoint rule and the left endpoint rule, given that increasing, right? So can you guys tell me which would go in which blank? Let me draw the left endpoint rule. Right, that would be like L5 in my silly picture. So is that an underestimate or an overestimate of the true area from A to B? It's an underestimate, right? So we put ln over here, right? What does the right endpoint rule look like? Well, the right endpoint rule is this one. It's an overestimate, right? So we put Rn. So this was essentially the this is the the punchline of the joke, which was Lab 5, if you like. It's the if Lab 5 was a sermon, this is the the critical point of the sermon. It's what I'm preaching about in Lab 5 is that left and right endpoint rules are either underestimates or overestimates for increasing function. Now, if the function is decreasing, the story changes, right? It's not always that ln is less than Rn, right? If I had a decreasing function, it would flippity floppity. Yep. Another area problem? Okay. Let's see if I can find one here. So I'll remind you guys again, we're not meeting Friday. I won't be around. But of course, if you've got email, if you got questions, you can, of course, email me, and I will try to help you eventually. Hopefully, I'll have internet at the hotel we're going to this weekend. I think our final is on Tuesday. All right, let's... Here, I found an old test. This is one of my old test 4s. So we'll look at it with the projector. You guys will be able to see it. The people looking on the video are going to be hopelessly lost because, as we've discovered before, there's a the projector in my whatchamacallit there, camera don't play well together. Actually, well, I'm not sure actually for a second here. Whoa. Oh, you know what I should do? I should post it in Blackboard, and then I can open it on this computer. If I can get this computer to... Let me start by posting the... I'll post it in tests and solutions. So this is my old test 4 from like Calculus 1 at Liberty from 2013, I think. So we had 4 tests in there because we had 5-day-a-week class, so it's like, you know, you get more time for oodles of tests. Oodles and oodles. So I will post a blank test 4 so you can try it for yourself. And I will copy, I will post the solution to my old test 4 as well. Let's see here. And we'll look through it. And now, of course, as you're studying for your test 3, the wise thing to do is to look over the homework solutions, right? Make sure you know how to, you know, do those problems. Now, one, you know, exception to that rule would be like, I'm not going to ask you to do the midpoint rule with 50 things. And if I was to ask you to explicitly calculate a, you know, a left or right midpoint rule, it would be one with like 4 points or something. And I probably won't do that, honestly. I kind of want all of your time and energy to be put on the integration and area calculating. Let's see if I can get this thing to work. Come on. Let us, other user. Other user. Come on. You can do it. You can do it. You can do it. All right. I'm going to get vertigo here if I'm not careful. What does that say? Can I hit? What was that? What are my options here? Can I escape from? Ah, very good. Calculus. Oh, man. I think you guys should be able to see it, right? Should be fine. All right, so I have oh, duh. I'm starting to do stuff on my laptop, which is really dumb because obviously we're not looking at my laptop up there, are we? All right. So let's look at the solution. And there we go. Come on. Where'd the full screen? I thought there was a full screen here. Where's my full screen? I thought, oh, there it is. All right. This blue thing saying, nope, what is that? All right. So, problem 1, FTC1, there it is. That's what FTC1 says. So the derivative of the area function is the function you're finding the area of. Under, rather. FTC2 is just what it says there. The integral of a function from a to b is the difference of the antiderivatives of that function evaluated at the endpoints, right? Now, technically, FTC1 and FTC2 has additional baggage, right? It's got like a sentence or two before these, which gives you the preconditions of the theorem. But these formulas are the heart of FTC1 and FTC2, right? This one here is just kind of like that homework problem you had, where I gave you an integral and told you another function was odd and asked you to do that integral. Well, this is kind of like that, but so here this is based on using that property of definite integrals, that it respects inequalities, remember, like 1 less than g less than 4 means that the integral of 1 is less than the integral of g is less than the integral of 4. But of course the integral of 1 and 4 is just 2 minus 1 times 1, 2 minus 0 times 4. So these integrals are just straight up 8 and 2, and so that has to be, that's the minimum, that's the maximum for the g integral. But of course this has added f. So you have integral of f is 3, so you integral g plus 3, so it's going to be between 5 and 11, because you, I mean, anyway, this problem is just kind of like, you know, about properties of integration. Moving on here. Problem 3. This was just like your quiz problem we just did, right? This time I give you the accelerate. Well, actually, it's a little bit different, isn't it? This one I give the acceleration as a function of time, right? In the quiz, I gave you velocity as a function of time. Since I've given you acceleration here, you have to integrate to find the velocity, and then integrate again to find the position. And I did it a little bit different here. So what I'm doing here is using, I do not want the new Java, leave me alone. But anyway, we integrate twice. Now, the way I wrote the integration, is using the net change theorem, essentially. So I'll write it over here. So we have v is dx dt, right? A is dv dt. So if we integrate from, say, 0 to time t, a of tau d tau, that's equal to the integral from 0 to t of dv d tau. So the introduction of the tau is a dummy variable of integration, and it's just to avoid using t in the same way twice. I have avoided doing this in class because I thought the way I've been doing it in class is maybe, I don't know, maybe it's simpler. It's really not different. So this gives you, I mean, that is whatever it is. There's a formula, you integrate it. For the problem that's in the test, this is literally a of t is t, so a of tau is tau. So you have tau d tau. Over here, you get v of t minus v of 0, because v is the antiderivative of dv dt. And so that's what led me to the formula v of t equals to v of 0 plus the integral from 0 to t of tau d tau. Like, that's what I wrote down on the solution we were just looking at. This is where that comes from. It just comes from the net change theorem. And similarly for the other integration. But let me move on here because you wanted to see about the area problem, right? So that's what I did there. See? V of t is v of 0 plus the integral of that, which is that. Okay, so, as I said, moving on. Here we go. So calculate area bounded by y equals absolute value of x and y equals x squared, right? So, as always, these problems start by drawing a graph. We have to understand the area which is being asked about, right? So you've got the absolute value and the parabola. Parabola comes under it. And so there's two different regions. There's this piece, and then there's that piece, right? And I just say, okay, by the symmetry of the problem, I can just double this piece, this area, by symmetry. And on this piece, the top y is x, and the bottom y is x squared. So I have y top minus y bottom times the thickness of the strip, which is dx. That's why I have dA there like that. Integral from, 0 to 1 ends up being 1/3. So I would say this problem is slightly easier than the one we had in your quiz, right? Because it's, well, I don't know, it's easier, but it's also harder, right? Because I don't know, maybe it's about the same difficulty, whatever, you decide which is worse, which is better. Problem 5 is literally an easier version of the one we had in your quiz, right? It's the parabola opens up one way or the other way. They meet at the y-axis. We draw a horizontal strip. We've got to find the points of intersection. They're at 1 and minus 1 for this one. Then we add up the area of those strips using integration. Oh! I can't read my own question. Oh no! My bad. Is this on your test 3? Why or why not? The answer is certainly not. Did we do volumes of revolution in here? No. So as you're studying my old test 4, should you ignore this problem? Yes, we definitely should. You could find the area bounded between those two parabolas, but that would be different. So what I'm calculating here is the volume that you get if you take one of those, take the parabola and like swing it around, take this like lemon shape and swing it around an axis. I think. Whoa, I shouldn't have done that. Now I'm busy. Let's see if I have more. So, and I have some plain indefinite integrals. I've got some, some U substitutions. Let's see here. So you can try these out. Problem 9, I probably wouldn't ask you guys because we haven't done that. I didn't have a homework problem like that. It's not outside the scope of what you've done. It's just not something we have emphasized. Problem 7 is a fair question for you all. Problem 8 you probably could do, but it's challenging. So that's about it. Again, so just to return to my previous thought, study missions 9, 10, 11. Right, make sure you're ready for those kinds of problems. If I've done a problem on the quiz that we've had in here, that means that it's on the top of my mind and it's something I think is reasonable to ask students under time pressure. Right? So anyway, see you guys next Monday. Thank you.